Okay, so this video is over 17.8. We're going to do another one very similar to the last one that we did, except this one has a stoichiometric coefficient. And so it's basically done the same, it's just with a little bit of a additional step when we were doing our change, when we were calculating how it changed. Okay, so equilibrium constant is 49. Okay, I've already given that to us. Okay, for the following reaction, 450 degrees Celsius, if 1 mole of HI is put into an evacuated 1 liter container and allowed to reach equilibrium, what will the equilibrium concentration of each substance be? So this one's even kind of different in the sense that we're going to be starting out with a product, and it's going to go back to the forward reaction. Okay, so let me zoom in here, write down a few things. So we know that Kc is 49, and that is equal to Hi squared over H2 and I2. Now, even though we're starting out with a product here and going back to our reactants, the 49 is based off of the reaction that's shown. Okay, so you're still going to write the expression as such. Over here, okay, if we were to add our Rice table, okay, we want to find out what our concentration values are. We know that we're going to start out with 1 molar. Initially, we have 0 starting out here, and since the reaction is going to be happening in this direction, we are going to be taking away some value to x because of that coefficient, okay, and adding the change of x there. Okay, so at equilibrium, you have some concentration x, some concentration x, and here you have 1 minus 2x. Okay, so once we get all of our values, we can now plug those into our equilibrium expression. Okay, so this is 49 is equal to 1 minus 2x squared. Okay, x times x. Let's take the square root of both sides, just like we did. Okay, and what we get here is 7 equals 1 minus 2x over x. Solve for x. You know how to do that already. I'm not going to walk you through the algebra of that. X is going to end up being equal to 0.11 molar. Once you find out what x is, you can find the concentrations of each of the substances. So concentration of H2 is going to be equal to the concentration of I2, and both of those are equal to x. Concentration of HI, why this is being difficult, is equal to 1 minus 2x. If you plug in x, you're going to get 0.78 molar. Okay, and so what will the equilibrium concentrations be of the substances? There we go.